Hi, 7th grade. We are going to review the questions that many of us missed from our Topic 2 test yesterday. So let's review some of those questions, and then you will have the chance to retake those questions today. So the first one that was frequently missed was number 2 here. So you want to know, your friend wants to know if there's a proportional relationship between the number of slices of ham in a sandwich, which we see in our first column, and the number of calories, which is our second column. So we might be thinking of X and Y. Decide if the relationship between the number of slices in a sandwich and the number of calories is proportional. So we are looking for proportional, and that means that we are looking for a constant. And our constant is always that Y to X ratio. So I'm going to look at these values in my table, and I'm going to set them up down here. So in my first row of the table, I see a Y value of 54 and an X value of 1. So that would be 54 to 1. In my second row of the table, I see a Y value of 84 and an X value of 2. That would be 84 to 2, which if I reduce to lowest terms, I can divide the numerator and denominator by 2. That makes 42 to 1. So I'm already noticing that in my first two rows, I have different ratios. So right off the bat, I already know that this does not show a proportional relationship because I don't have a constant ratio here of Y to X values. So quick, easy check. As I continue this pattern, if I look Y to X, I could write that as 114 to 3, but as I continue, even if the rest of my values do come to a common ratio, I already have these two that didn't, so I can move on. All right, let's check out number 4. Does the equation y equals 3x plus 2 show a proportional relationship? So for this one, all we're starting with is our equation. And it's a little harder to tell in our equation if it shows a proportional relationship. So we could examine an XY table and figure this out. But let's check out our answer choices. This could be proportional if the graph of the equation is a straight line, or if the graph of the equation is a straight line and passes through the origin. That would be both of the criteria. It's not a proportional relationship if the graph is not a straight line, and it also would not be if the graph does not pass through the origin. So let's talk about how we can tell. If you want the shortcut version, anytime we are adding a number like this plus 2, we're adding that to our x term, we automatically know this is not going to go through the origin. It's going to go through the y-intercept at positive 2 instead of at 0. But if I'm not sure, then let's set up an x, y table. So I'm going to put in just a couple numbers here, and I'm going to start with 0 for x because I want to know if it's going to go through the origin. So I'm going to substitute 0 into my equation for x, which means I'm going to do 3 times 0, which is 0, plus 2. So right off the bat, I see that it's going to go through the point 0,2, not the point 0,0. So this graph does not go through the origin. So not a proportional relationship. All right, the next problem we're going to review is number 6. Suppose you want to buy bouquets of flowers for a party. An equation that represents the cost y in dollars for x bouquets is y equals 12x. I'm trying to decide if this equation represents a proportional relationship. I need to decide yes, it's a straight line and it passes through the origin, or no, it's not a straight line, or no, it does not pass through the origin. So as I'm looking, I see that I'm not adding anything to this x term, which tells me it probably goes through the origin. But let's check it out. So I'm going to make my xy table, and maybe I will pick just a few points here to check in my equation. So if I've chosen an x value of 0, I'm going to put that in my equation for x. So 12 times 0 would be 0, which is good news because now I know that this does go through the origin. So far it's proportional. Now let's substitute 1 into my equation. If I put 1 in for x, 12 times 1 is 12. Now I'm going to substitute 2 into the equation for x. 12 times 2 is 24. And if I put 3 in for x, 12 times 3 is 36. So now I can look at my table. I already know it does go through the origin. So let's make sure it's also a straight line. And I can tell that if I have a constant ratio, or in other words, my y to x stays the same. So looking at my table, I will look at my first point that doesn't go through the origin, which is 112. And if I'm going to look at y to x, then that would be 12 over 1. My next point in the line is 224. So when I look at y to x, that'd be 24 over 2, which I know reduces to 12 over 1. And looking at the third point in my table, 36 over 3 will also reduce to 12 over 1. So I see a constant ratio in my table of 12 to 1, so I would say yes, this is proportional. For number 7, we know that the variable y is in a proportional relationship with x. The number of squares represents an x value. The number of ovals represents the corresponding y value. Identify the constant of proportionality. My constant of proportionality is k, which is my y to x ratio. So if my ovals are y, then let's count up my y values. I have 5, and 4 is 9, plus 3 is 12, plus 2 is 14, plus 1 is 15. So my y value is 15 and my x value is 3. So this ratio is 15 to 3, which I could reduce to lowest terms of 5 to 1. The simplest way to write that is the number 5. So that is my constant of proportionality. Let's check out number 11. This equation describes a proportional relationship between x and y. What is the constant of proportionality? Well, this is an easy one because my equation is y equals kx. My constant is k, so it's always the number that I am multiplying by x. It's my coefficient of x. So in this case, 5/8 is my constant of proportionality. On number 13, when I'm solving the proportion, 22/20 equals x over 70. Well, I notice that I can't take a 20 and turn it into a 70. But I do have two other strategies. So the first one is I could take this fraction here that's complete, this ratio, and I could reduce it to lower terms. So if I divide the numerator and denominator both by 2, 22 divided by 2 is 11. 20 divided by 2 equals 10. So I can rewrite this proportion as 11/10 equals x over 70. Well, now I do know how to turn a 10 into a 70. I'm going to multiply by 7. Whatever I do on the bottom, I also must do on the top. 11 times 7 equals 77. And I have just solved my proportion. The other method you could also do that we briefly talked about is the fishtail. If I start at the number opposite of the x, so I'm going to start at 70 and I draw my fishtail, I'm going to multiply, divide by, equals. So 70 times 22 divided by 20 equals x. 70 times 22 divided by 20 equals x. So as I do this, now I'm going to multiply 70 times 22. And when I multiply that, I get 1,540 divided by 20 is 77. So two different ways we've talked about to do that problem. On number 14, an arts and crafts store sells sheets of stickers. Use the table to write an equation you can use to find the total cost, y, in dollars for x sheets of stickers. So my equation is going to use the form y equals kx. So all I need to do is in my table find my constant, k, which is that y to x ratio. So let's look at the first row in our table. Y to x would be $7.65 divided by 3. Okay, so when I divide that out, 765 divided by 3, I get $2.55. So let's look at the next row in my table. As I look at the y to x ratio, I have 1530 divided by 6. And when I divide that out, I also get $2.55. As I look at the third row in my table, I have $28.05 as my y to x, which is 11. And as I divide that out, I also get $2.55. So I am finding a constant ratio here. So $2.55 is in fact my k value. So my equation should be y equals 255x. Taking this constant ratio here and substituting it in as the k in my equation. All right, last couple. The scale drawings. We all need a little more practice with the scale drawings. So remember, we're always going to start by writing our scale as the first ratio in our proportion. So I'm going to put 1 centimeter over 2 meters using my scale as it's written here. Now I need to find the actual area of the tennis court. So to do that, I need to find the actual width and the actual length. So this is going to be a two-step process. So I am actually going to slide this over, give myself some more room. Let's start by finding our actual width. So in the model or the scale drawing, the width of the tennis court is 6.5 centimeters. That goes in the top of my proportion because it matches up with centimeters in my scale. Now I'm looking and I see that to turn 1 centimeter into 6.5, I need to multiply by 6.5. Whatever I do on top, I have to also do on the bottom. And when I double 6.5, I get 13. So that means that the actual width is 13 meters. So let's do that now for the length. Let's find the actual length. So I'm going to start with my scale. And I'm going to fill in what I know. I know the scale drawing length, which is 12 centimeters, and that goes on top because that matches with centimeters in my scale. And it's the actual length in meters that I'm trying to find. So I see, okay, to turn a 1 into a 12, I'm going to multiply by 12. If I do that on top, I have to do that on the bottom. which would give me an actual length of 24 meters. So now I have my actual measurements, and I can use those to find